Now we have to learn about Pythagoras theorem. Pythagoras theorem gives the relation between the three sides of right angle triangle. This is right angle. Consider this triangle ABC. Now, according to Pythagoras theorem, hypotenuse square is equal to, now in this case, angle B is right angle, so side opposite to angle B, which is AC, is hypotenuse. So hypotenuse square is equal to base square, in this case it is BC, plus height square, in this case it is AB. In a given triangle ABC, angle ABC means angle at point B is 90. So according to Pythagoras theorem, hypotenuse square, that is AC square, is equal to base square, that is BC square, plus height square, that is AB square. Now we have to prove this Pythagoras theorem. This theorem states, in a right angle triangle, the square of hypotenuse is equal to the sum of the squares of the remaining two sides, is equal to the sum of the squares of the remaining sides, means square of base and square of height. First we have to write given. As we drawn here one triangle ABC which is right angled at point B, therefore the statement of our given is, in triangle ABC, angle ABC is equal to 90, means angle at point B is 90, it is right angle. Now see what we have to prove. Hypotenuse square, that is in this case AC square, is equal to base square plus height square, that is in this case BC square plus AB square. Now see construction. We have to draw segment BD perpendicular to hypotenuse AC. Now see proof. Now in this case we have drawn one right angle triangle ABC as our given, and because of our construction we drawn one perpendicular BD. Because of this perpendicular BD, the whole triangle ABC is divided in two parts, again in two right angle triangles. One is ADB, which is in left side, and other is DBC, which is in right hand side. So we have to use these three triangles. We have to make pair of each two to show their similarity, and then by using similarity of these triangles we have to prove this Pythagoras theorem. Now see how. In triangle ABC, segment BD is perpendicular to hypotenuse AC according to given construction. First we have to consider two triangles. One triangle ABC means whole triangle, and second triangle ADB, which is in left hand side in diagram. In these two triangles, angle ABC from first triangle, means from triangle ABC, is equal to angle ADB from second triangle ADB, because each angle is of 90 degree, means each one is right angle. Angle A is equal to angle A, because angle A is common angle for these two triangles. Therefore, triangle ABC is similar to triangle ADB because of a test of similarity. As we know, if triangles are similar, their corresponding sides are in proportion. Therefore, we can write AB of first triangle upon AD of second triangle. Both these are corresponding sides from these two triangles. This ratio is equal to ratio of side AC from first triangle upon side AB of second triangle. Now this time this AB for second triangle, triangle ADB. Again this AC and AB both are corresponding sides. Therefore, by cross multiplication we get AB into AB, that is AB square is equal to AC into AD. Consider this statement as number 1. Similarly, we can prove another pair, means whole triangle ABC and right hand side triangle BDC similar, again by same test of similarity AA, because in these two triangles again one pair is of right angle, which is corresponding pair equal, and other angle means angle C is common between these two. Therefore, we can write their corresponding sides in proportion. BC upon DC means ratio of corresponding sides of these two triangles is equal to AC upon BC, the ratio of another corresponding sides of the same triangles. Therefore, by cross multiplication we get BC into BC, that is BC square is equal to AC into DC. Consider this statement as number 2. Therefore, by adding statement 1 and 2 we get addition of left hand sides, that is AB square plus BC square is equal to addition of right hand sides, that is AC into AD plus AC into DC, which is equal to, by taking term AC common we get AC into, in bracket remaining terms, AD plus DC is equal to AC into value of this bracket AD plus DC, where A, D, C are collinear and D is in between A and C, is means AD plus DC is AC, is equal to AC into AC, that is AC square. Hence we proved Pythagoras theorem. AC square is equal to AB square plus BC square, that is BC square plus AB square.